Good afternoon, and welcome to the session. During today's session, we'll walk you through best practices for cloud governance at scale. My name is Svetlana Kolomeyskaya. I lead the worldwide specialist team for cloud governance and identity. And I'm here today with Nivas and Eric. Would you like to introduce yourselves?
Hi, everyone. My name is Nivas Dorey-Raj. I'm a cloud governance specialist based out of Chicago.
And hi, everybody. I'm Eric Westphal. I'm a principal specialist for cloud governance and security, working across all of our governance and security services. So nice to meet you.
So let's start with what customers have asked us, the questions we heard from you. And we've spoken to thousands of customers, large and small, in different industries, geographies, and also at various stages of adoption journey. You might be going through a migration project, moving one or more workloads to the cloud, or maybe you're launching a new project. For example, launching a new serverless application for your customers, or you're undergoing through some type of organization transition, such as mergers and acquisitions. So how do you set up the right foundation with the right rules and policies to help you set you up for success, not only for the current project, but future projects as well? You might be a customer in a regulated industry, for example, financial services, public sector, or healthcare and life sciences, and you need to adhere to certain regulatory requirements and common frameworks such as HIPAA or PCI, or you'd like to roll out corporate standards across your organization. For example, maybe you don't want to disable specific services, for example, CloudTrail for auditing or guard duty for within your organization. And lastly, how do you drive agility in development of new projects to help support your business, to drive efficiency, to drive optimization for developers? For example, you're launching a new project, so you'd like that new environment or new account provisioned to you in a matter of minutes, right? Or maybe through self-service versus waiting for some centralized architecture or central cloud team to provision it to you. Strong governance helps address these questions. It's at the heart of every successful cloud journey, and it is a journey. You don't have to get there day one. You start with the right foundation, and you continue to evolve, and you iterate as you bring more workloads to the cloud or launch new projects. So what we'll cover today, we'll cover overview of cloud governance and why to use cloud governance. Then we'll dive into 10 specific cloud governance best practices that you can take home with you and implement within your organization. And that's across cloud environments, controls management, and cloud governance for developers. And we'll also show some demos. We all love demos, so we'll have that for control management as well. So let's start with the definition of cloud governance before we dive into other areas. And there are a lot of definitions of cloud governance out there, and we wanted to share with you our definition. So cloud governance helps you manage the use of cloud services and resources in accordance to your business objectives, so your business goals. And based on your business objectives and goals, you set up several different rules and controls within your environment. And also cloud governance is not just about technology. It's about practices as well. Implementing the right procedures, for example, allowing or disallowing the use of specific services within your organization. And lastly, it's about reports. So audit, assessment reports to provide feedback loop so that you have visibility and also to ensure that the right set of cloud governance rules and practices are in fact being followed. So when do you need cloud governance? First, to set up your core foundation. When you are building a new house, you need to have your foundation, you need to have your walls, you need to have your doors that lock to make sure you're safe. So that's the cloud environment for your migrations, for your new projects, for organization transitions such as mergers or acquisitions. And that's when you set up your account structure, right? Your account strategy. You also harden your accounts with security controls in place, with networking controls in place. In AWS, we have different services, for example, AWS Organization Control Tower to help you set up your cloud environments. So we have customers such as FactSet. FactSet is a financial data and software company. They've been a customer for many years, and they wanted to go faster, and they wanted to accelerate projects. So they've implemented AWS Organization and multi-account strategy, and they provided their teams their own environment and separate accounts with all the controls built in. And as a result, they were able to accelerate project onboarded 5 times faster. You also need cloud governance to comply with your regulatory requirements and corporate standards. For example, frameworks such as HIPAA, PCI, SOC, and corporate standards that you'd like to roll out across your organization. Also, many of our customers have data residency requirements to ensure that the data is stored in a specific location or geography. And then all of these standards and all these requirements, it's not just one-time setup, right? As these requirements, the standards, they evolve every day. So you need to have that environment that can adapt to those changes. So within AWS, we have various managed controls and policies to help you to meet these requirements. For example, AWS Organizations, we have service control policies, SCPs. Also, Control Tower offers data residency controls as well. Region deny is actually one of the top used controls that we have out of 350 controls available. And we have customers such as Bristol Myers Squibb. It's a highly regulated customer in a global pharmaceutical space. And they operate all over the world. They have different regions, and they have application that store patient data. So data residency is a very key requirement for them. So they've been able to implement AWS Control Tower and programmatically set up guardrails and data controls, not only from the beginning, but also make changes as their data regulations evolve. And finally, you need cloud governance for developers to ensure deployment consistency and also configuration enforcement. For example, let's start with maybe predefined infrastructure as code templates versus starting from scratch, with security controls, built-in networking, and cost-effective options, and also configuration enforcement, specific instances that you can use or access to specific S3 buckets. And then faster project delivery, with things like automated account provisioning or provisioning of environments. So customers like Symetra, it's an American insurance company, it used to take them days to get a new environment provision, a new account provision for them with lots of manual steps. So they started leveraging the account factory feature of Control Tower, and now they automated their provisioning of accounts and environments, and now they get them in less than 30 minutes, so they can go faster and implement new projects with all the corporate policies and controls in place. And cloud governance, it's not just about technology. It's about people and process as well. Most organizations have a central cloud team. Sometimes it's called Cloud Center of Excellence, but there are many other names as well. And this particular central team is responsible for bringing all of these 3 aspects together. So it's not just technology, but also driving cultural and organizational change. So they're champions within the organization. So they, for example, provide sponsorship or seek sponsorship or executive buy-in for different projects, for different tools. They also drive different or implement different education paths for different teams. Not only about AWS services, but also organizations' best practices around these particular services. They also define different best practices, how to roll out organizational-wide guardrails and corporate standards across the organization. But they act as an enabler, not a blocker, right, to the organization. So they work with different teams to gather use cases, to gather requirements, to bring them into those corporate best practices. So I have a link here, the QR code for People Perspective for Cloud Adoption Framework. That we can get more details about the people perspective, but also building the central cloud team. So cloud governance at scale. With the right foundation, the managed control, the right practices, procedures, it helps improve security posture, compliance posture, and visibility within the organization, and as a result, driving or increasing agility and really freeing up time to accelerate innovation to help support your organization business growth. So with that, I will turn it over to Nivas, who's going to start walking us through those 10 best practices, starting with one for cloud environments.
Thank you, Svetlana. Okay. Here's what our customers have told us about building cloud environments. Provisioning accounts is time-consuming. It's difficult to scale our environments, or we have to manually configure our accounts. Last week, I was speaking with a customer, and they wanted to set up their cloud foundational environment. I thought it was going to be a simple response. Start with Control Tower, set up a secure, well-architected environment with AWS Organizations. But then the customer said, I have 4 or 5 environments. Again, I thought, a little bit simple. Let's bring those accounts into organizations, consolidate the billing, and then bring them into Control Tower's governance to improve their security posture. But then the customer commented and said, I don't know what's in the 4 or 5 environments. And that meant I had to change my guidance. And this is not an uncommon scenario. It's actually quite common because our businesses are dynamic. They're always going through mergers and acquisitions, and so you may inherit an environment that you don't know what's happening. But it's important to know what's going on in that environment to apply cloud governance best practices. Now, going back to these challenges behind me, the good news here is that it's quite simple to resolve. It just takes a good investment of time, resources, and prioritization. So this brings us to our very first best practice. Use accounts as building blocks. And the reason for this is that you can think of accounts at AWS as natural security boundaries. They help you isolate your workloads and act as natural data perimeters. There are other advantages as listed out here on this slide. But let me give you an example. If you have all of your workloads within one single account, and if for some reason an unauthorized entity gets access to that particular account, all of your workloads are impacted. But if you had used a multi-account model, this would have reduced the security blast radius. Then you also want to group your accounts into organizational units, because that will let you apply service control policies that will enable or disable API activity within the accounts. And to do that, you need to have a proper organizational unit strategy. And we have some recommendations here. Start with foundational organizational units. So these are your security OUs and infrastructure organizational unit. Underneath the security organizational unit, you will find a centralized log archive account, as well as your security accounts. Your security accounts can contain tooling like the config aggregator, and as well as act as a break glass account in the event of an issue. Underneath the infrastructure organizational unit, you will find shared services infrastructure. Could be shared VPCs, could be shared CI/CD pipelines, could also be shared libraries of templates that you share out across your multi-account environment. In this OU structure, we have some additional organizational units, a sandbox OU. And in the sandbox OU, the thing to remember here about these accounts is that these are disconnected from your production network. That means workloads in the sandbox accounts cannot access sensitive data sets. Then with the workloads OUs, you can set up production workloads, test workloads, pre-prod workloads, and so on. The QR code directs you towards a white paper that gives you more details on other organizational units that you can create, such as a policy staging OU, suspended OU, deployments organizational units, and others. But create organizational units when you need to. You don't need to create everything that is described in the white paper. The other part about creating organizational units, ensure that it is based on common policy groupings versus your business structure. So that means your production workloads are in the production OU because the policies that are applied to the production workloads are different from your test workloads, which will find themselves underneath a test organizational unit. Cloud environment best practice number 2. Enable visibility to track user activity and risk. Over here, we recommend centralized logging in a multi-account environment. And one, this will reduce risk in the event of a data breach, but also it will help you draw insights into what's taking place across your organization. You'll be able to use that information to come up with policies, controls, as well as bring up or introduce more efficiencies to the mechanisms and processes that you've applied within your organization. The second is ensure that the data that you're drawing from your member accounts remains the same as what's in your source. So this has to do with data integrity, as well as confirm that the data is coming right from your member accounts versus coming in from other external accounts. So organizations gives you org-based CloudTrail, so it helps you there. And AWS Config helps you assess, audit, and evaluate the resource configurations and the relationships between resources. CloudTrail Lake, a relatively new announcement, and over here, you can use that to run SQL queries on your CloudTrail events to draw insights. Just as of yesterday, we launched out-of-the-box CloudTrail Lake dashboards, which will help you get some insights and trends about the data. Cloud environment best practice 3. Automate account provisioning and customization. So for this one, we'll want to introduce standardization and consistency to the accounts that we are provisioning in our multi-account environment. And this has to be done through automation, because if we were to manually configure the accounts, it's going to result in a buggy environment as well as resource misconfigurations. And here, you'll want to consider customizing the accounts with platform customizations, such as for networking, security, identity, controls, and compliance. Some examples are enabling guard duty across your accounts. And then depending on the type of account, maybe it's for an analytics team, you may consider enabling Macie plus CloudTrail data events. Really depends on what your customers and client teams are doing within the accounts. Third, on self-service. Here, essentially you want to make sure that the central IT team doesn't become a bottleneck for your customer teams. They should be able to provision their accounts and customize it through self-service. And you might use a ticketing system to help you do this, but it's all about enabling the agility of your development teams. And then with domain-specific environments, again, considering the background of your teams, if your teams are coming in from an ML background, then customize the accounts accordingly so that they can pick and choose the tools and services that they need. In the ML example, it might be SageMaker Studio, might be ML-specific containers, as well as pipelines to help them train models and build out endpoints for inferencing, as an example. Our fourth best practice for environments is apply the principle of least privilege. Here, you'll want to restrict access to the management account. Why is that? Well, the management account is quite powerful. By minimizing the workloads and making sure it's a limited few that can access the management account, you're ensuring that the controls cannot be changed on the member accounts because you can do that from the management account. In addition, the management account has visibility across the multi-account environment. Customers also do not want to limit access to the billing data within the management account. Second, consider balancing least privilege access. So here, this is all about ensuring that your identities are permitted the smallest set of actions to complete a task. So for example, if an administrator is responsible for 400 accounts or so, it's not necessary for that individual to have star permissions with administrator role to access the accounts. Maybe for their daily activities, they should be able to get away with a read-only based role. And then third, require MFA for your users with elevated access. And then we come down to Identity Center. The recommendation here is if you are using an existing identity provider, like Ping, Okta, Microsoft AD, it is integrated with Identity Center because Identity Center simplifies the access to your accounts in a multi-account environment. You don't have to manually configure access in the accounts. And then it also gives you some other advantages like temporary credentials for the users and centralizes the management of roles and policies and access to the applications like SageMaker Studio, Salesforce, Box, and Microsoft 365. Okay, putting this all together is our service, AWS Control Tower. And AWS Control Tower is unique at AWS because it's a solutions-based service. It orchestrates multiple services, organizations, Identity Center, Config, CloudTrail, and more. As you can see here, it's set up security OU and a sandbox OU, giving you a very good starting point. But the key here too to understand is that you can extend the capabilities of Control Tower using the underlying services. So with organizations, you get other service integrations that you can implement in your Control Tower environment. All right, we also have a rich partner ecosystem. And here, if you're looking for other capabilities, you can pick and choose our partner products that cover the governance categories of controls, identity, security, and more. And some customers also like to use partner products that they're already using in an on-premise environment. So this gives them the opportunity to use something that is familiar. Here are the key takeaways. Again, to summarize, use accounts as building blocks, enable visibility to track activity and risk, automate account provisioning and customization, and then apply the principle of least privilege. And now Eric's going to come and talk to us about controls management.
Thanks, Nivas. Oh, click here. Thanks. So, as we talk about applying some of the principles that Nivas was talking about, one of the mechanisms that we use to do that is applying security controls across our environment. So I'm going to give a quick primer on security controls in the context of governance, and so that we're all speaking the same language here. The first place and the foundational component, and it's very important to start your security controls conversation from a early stage of looking at high-level expectations across your organization through establishing policies, right? And these might be, how do we accomplish our regulatory requirements, our statutory requirements, contractual obligations, those types of things, right? What does good look like for us? What are we on the line for? And then from there, using those policies to inform control objectives, which are really intended to identify the conditions to meet, right? This is the definition of what good looks like. This might be all customer sensitive data is stored encrypted, and the inverse of that must always be true, right? The invariant that there is never customer sensitive data stored in an unencrypted manner. After you have defined control objectives, you map standards, which are your formal requirements, right? These are things that satisfy control objectives. So standards like, again, going back to our example of making sure that customer-sensitive data is stored in an encrypted manner might mean that we must have certain KMS keys, we should have those managed in a certain way, and that all durable storage like S3 buckets or databases leverage those keys in a standardized fashion. And then from those standards, we map security controls to standards, right? These are the things that we use to establish safeguards to meet those standards. All security controls map back to standards, but not all standards map back to a security control. So it's important, though, that if you find yourself with a security control and you can't answer the question of what standard is this enforcing, you probably missed a step somewhere. So now that we've talked about the journey of sort of defining what security controls you should establish in your environment, we're going to talk about the different types of security controls that you might establish across your environment. And one of those is detective controls. These are the types of controls that you're going to use to detect configuration risks, misconfigurations, policy violations. These occur after provisioning, so this is a post-provisioning life cycle. But in some cases, we might find that we've attached automated remediation to detective controls, making them remediative or reactive controls, right? So this is if, again, going back to our earlier example, we have an S3 bucket that's storing customer-sensitive data, and we find that it's unencrypted. We may have a detective control to detect that, and we may attach a remediation document through something like Systems Manager, automation, or some other form to actually go out and reconfigure that bucket so that it is in compliance with the control, and then call back to the control, reevaluate it, and make sure it goes back into compliance. We also have preventive controls. These are things like service control policies in AWS Organizations, and these are things that prevent or disallow an action that would otherwise violate your security policies, right? This is a great way to sort of just stop misconfiguration risk and security violations before they ever occur. This is an ideal state, but this is also not always possible, and there's a lot of reasons why, and there's a lot of nuance here. Proactive controls are another way to sort of prevent misconfiguration risk from being introduced in your environment through evaluating a resource, modeling a resource before it's provisioned at runtime, whether it's a CloudFormation template or a Terraform module, evaluating those resources against a set of policies and determining if we were to proceed, will this violate our security policies or not, and then making a decision about whether or not to allow that to proceed. This is a great way to complement preventive controls to allow you to be a little bit more nimble and to shift that security a little left. So, controls management best practice. This is our best practice number 5. Really, at the end of the day, what we want to do here is make sure that we're defining our controls as policy as code models and enforcing a peer review mechanism for those. Security controls form the foundation of the entire environment in which you run your sensitive workloads, run your business, right? And therefore, we need to treat them in the same way that we treat all of our other software that we're developing. We should have rigorous standards, making sure that we're going through pipelines, making sure that we're subjecting those code changes to peer review so that somebody's not introducing a risk. And so simplifying and standardizing that control engineering methodology, right, is very critical to making sure that you have a consistent output as you're building out controls to implement your standards. Also ensuring that quality control through peer review allows us to also reduce work inversion, right? Where we start to implement a bunch of controls on our developers and shoving a bunch of work over the wall to them, right? If we're going to be doing that, say we're going to enforce some new standard, they should have the opportunity to voice an opinion before those things are applied in their environments, so they at least understand the context in which they're being applied and the reason why. Using high-level declarative languages like CloudFormation, Guard, or OPA, or Open Policy Agent, or any sort of other human-readable policy language is really about promoting that safe and fine-grained control capability while keeping those accessible to people, right? It lowers the barrier to entry, allowing sort of non-experts to be able to take a look at those policies, understand what the intent is, and evaluate that without having to sort of dive into deep code. Controls management, best practice number 6. We want to align the control objectives that we've defined from our policies to a security framework, and do this in a more formal fashion than sort of just ad hoc deciding that, well, yeah, it's a good idea that we encrypt all of our customer sensitive data. What we want to do is ensure completeness and consistency and adhere to industry best practices, especially if you're under regulatory requirements or statutory requirements. To be able to evidence that to auditors is critical. This is going to make sure that you don't forget anything, right? Like, it's very easy as you get into large-scale environments, hundreds, thousands of accounts, all sorts of different kinds of workloads, different AWS services, to think you have all of your control bases covered, but if you don't have some sort of standard that guides you for that process, it's easy to miss something. Right, so as we look at these things, a security framework, again, consistent, repeatable foundations. How do we address risk? How do we define risk? How are we mapping controls back to risks and control objectives to risk? Things like NIST 853, or the Cloud Security Alliance's Cloud Controls Matrix, the well-architected framework. There are all sorts of options available to you out there, QR codes that point to some of those standards I mentioned. These are excellent examples to help you get started and to also help you define formally what your process should be, how you should address risk, and how you can measure and quantify your control story. This is also important to note about measuring control effectiveness, right? If we don't understand what we're trying to mitigate, what risks we're trying to mitigate, we won't have a quantifiable baseline for defining whether or not a control is actually effective or not, which sort of leads us into the next best practice. As we start to roll out these preventive controls or our security controls in our environment, it's critical to layer defenses across your environment, use preventive controls to protect critical security baselines, and security invariants. Think of security invariants as things that must always be true. Right? Something that you can boil down to a Boolean sort of true-false scenario. We should never allow unauthenticated users to sort of get into our system. That might be an invariant, right? Working backwards from that, you can start to break that down even further into what properties of a system need to be true in order for us to meet that promise of only authenticated users are allowed to access their data, and monitor those invariants, right? But using preventive controls to protect those baselines means that we can confidently put something out into environments, as Nivas and Svetlana mentioned earlier, around customization of your environments. If you put security resources or configuration baselines into an account, you want to make sure that the only authorized people are making changes to those. Using proactive controls and detective controls allows you to stop and detect security misconfigurations before they're deployed, or again, having a detective control for post evaluation still ensures that if somehow somebody gets past one of those other controls, that you have a mechanism to detect those and evidence that they've been mitigated. So, as we mentioned, right, enforcing those invariants and enforcing protection, safeguarding those critical baselines is one of the best ways that you can accomplish this. Again, stopping that security misconfiguration before they're deployed into your environment. One, as like Nivas was mentioning earlier, let's try to reduce our attack surface in the first place, right? Rather than have something get deployed into our environment and then have to remediate it or fix that or treat that risk, we're better off just stopping it in the first place, right? This also serves to let us shift responsibility for remediation to our developers, right? We detect it early in the pipeline, they get visibility into why it failed, and the responsibility for fixing that now is on them to go back, fix their misconfiguration, and try again. Lastly, continuously monitor and test control effectiveness. This is really about controls are never a set and forget operation. You can't just put a control out and leave it and then move on to the next thing. One, we need to know quantifiably how is this control operating? Does it actually work the way we think it does? Does it actually mitigate the risk that's underlying? What is the control objective that this control is mapped back to? And are we effectively mitigating that risk, right? And this is a continuous process. Once we've set it and it worked on day one, how do we know a year from now that that control is still operating the way it did on day one? Have we introduced a regression? Have there been changes over time? The environment may have shifted under us. We may have introduced new AWS services or new interactions, and the objective that we were initially mitigating may have changed to some degree as well. So we need to make sure that we're constantly monitoring our controls, quantifying them, and making sure that they're actually doing what we think they're doing. Using things like unit testing, canaries, integration testing, right, under realistic scenarios. Like think of using threat actor behavior, TTPs, adversary, breach attack simulation. These types of things are the next sort of evolution of controls management, allowing you to make sure that you can actually evidence and prove that not only do you have the controls to mitigate risks, so that we move past a checkbox to actually being able to prove that the underlying threat is actually mitigated. All right, so with that, we'll switch over and we'll talk a little bit about how we go into implementing these with services like Nivas was talking about earlier, Control Tower. With Control Tower, we have comprehensive controls management capabilities that allow us to really get a visibility through a controls library of, Lord help me if the internet is actually working, but allows us to sort of map back controls in our library to control objectives, frameworks, right? And we get to see things like metadata, right? So in addition to what control is it, we can start to group them by control objective. We can start to group them by what AWS service are they related to, what frameworks are they mapped back to, and what, within those frameworks, what control objectives are they addressing, right? This allows you to, one, deduplicate controls to make sure that if we're needing to address some sort of underlying risk in NIST 853 and PCI DSS, where we're not deploying the exact same control twice just because we have two different regulatory frameworks that we need to meet, right? Additionally, this allows you to evaluate where are these controls enabled. So now I have a single place to come and look at this particular control that meets this objective, that meets this framework standard, is deployed at these locations in my environment, right? And I can also understand what is the underlying artifact for those controls. So in this case, this is a proactive control inside Control Tower, and we can see full visibility into the CloudFormation Guard policy that underlies this control. We can see things like the gherkin here, which is a way for us to define the scenarios under which this control should operate and what the end result should be, right? So this is a testing framework. And with that, we also get positive and negative test case exemplars, right? So we have a template in here that's going to should pass this control, and we have a template that should not, that should fail this control, right? And so these are a very good starting place for you to start testing these controls for efficacy, to actually make sure that they're doing what you think they're doing, and at least ensure that they're consistent and correct behaviors. So with that, we'll look at some of these in action. So what I'm going to do is just from a developer's perspective in an environment like this, deploy some resources that should violate a detective control and see how that experience is. Again, we're going to look at a detective control, so remembering that this is a post-provisioning type of control. So all I have here is a CloudFormation template to deploy an S3 bucket. And this bucket does not have versioning enabled. So what I've done in our environment is if we come in here and look at our controls, I've deployed a control that is detective against this environment here. And again, I can filter these down by behavior and look for detective controls. And as we can see here, somewhere in here, we can see this control here, detect whether versioning for S3 buckets is enabled. So this control is going to be an AWS Config rule, which will evaluate that S3 bucket when it's created automatically and determine whether or not it's compliant. And then this is also an opportunity where if we want to attach some sort of automated remediation to that, we could do so as well. So if I go and execute this CloudFormation template here in our production environment, this will succeed. And I've now violated our policy standard that all S3 buckets that hold sensitive data must have versioning enabled. And after a few minutes here, what's going to happen is AWS Config will automatically detect that resource creation occurred, model that out into what's called a CI or configuration item, compare it against the compliance standard under that rule, which is that versioning should be enabled, and determine that it is in fact non-compliant. So if I go and look, we can go verify that our bucket was created. So we're still waiting. But as we can see here, versioning configuration is suspended. So this should violate, and as soon as it's finished, there we go. So our bucket is created, and if we go check, maybe. Oh, wait. No, that's why. I'm in the wrong account. Apologies. But suffice it to say, if I come up here and look at an earlier example of this, what I should see here is a non-compliant example response here. There we are. I had it. So moving on from this particular one here, if we move on to what is a better option for us, this is not how you want to depend on controls across the board. If you can't avoid it, you want to stop those risks, as we said, before they're introduced. So we'll look at this same model here. What we have now is a proactive control, which will run in our dev environment. And what this should do is, I've said that this no S3 bucket should that has sensitive data should be allowed to store data unencrypted, and it shouldn't be public, right? This CloudFormation template, if we look at it, does not have default encryption turned on, and so should violate that policy. What we want to see here is that this control will actually fire a CloudFormation hook behind the scenes, and prevent this configuration from ever getting in our environment in the first place, right? So if I execute this stack, and we go and monitor our operations, okay, what we will see is it starts the process of creating the resource, and it's going to invoke a hook. And so we can see that here is it's gone out and fired off this control tower CloudFormation hook and passed it a model of what that resource configuration is. And we'll see that here. Here's the resource configuration model, the properties that are relevant to the rule. And in this case, we can see that nowhere in here does it actually have any sort of encryption configured, which should violate it, right? And so as it goes and evaluates that resource model, we can see that the hook failed with a message, a validation error. And here we have our control ID and a message back saying that Amazon S3 buckets must have some sort of server-side encryption configured. And here is your remediation instructions, right? Set an encryption rule in the bucket encryption, server-side encryption configuration, and configure it correctly. So now what we've done is instead of having to have somebody sort of raise a ticket and go chase somebody down to remediate a security violation, we've stopped it from ever entering our environment. And now we've also told the person who would have violated that policy what was wrong and given them some suggestions on how they might go about fixing it and try again. So we've shoved all of that responsibility for remediation off to the person who's responsible for actually creating and managing that resource, which is in an ideal state, right? So if I go and delete that, because it's now violated, and we clear that out, and I go and follow those instructions and actually fix this, I might come in here and set a bucket encryption stanza like they suggested, right? And in this case, I'm just going to tell it to use AWS S3 SSE encryption, not KMS. And I'm also going to enable bucket key. So if I go and inject this into my formerly failing resource and run this again, what we should see is this will pass after it goes through the same hook that we saw before. So our template has been submitted and it was successful. So we'll go in and look. We've started our resource creation. We've modeled our resource configuration. Now we see that there is in fact a bucket encryption configuration in this model and that it's got SSE turned on in a correct way. We can see here that the hook is set in failure mode. You can run CloudFormation hooks in different models so that you could instead just be advisory. In our model, because we're actually running a security control, we want to stop the pipeline from proceeding. But you can run hooks in advisory modes as well if you set up custom ones. And as we can see, the hook completed successfully. There were no errors. And now we've moved on. Hook invocations are complete. And we're actually creating the resource. And here we are, resource creation in progress. And if we refresh this again, we should see a successful bucket creation. Yeah, right here. So create complete. So if we go in that account and look, there we go, bucket versioning is enabled, default encryption is enabled, and our bucket key is enabled. So we were able to create the bucket without involving anyone else, and we were able to enforce our security standards and stop the risk from ever being introduced into our environment. This is an ideal state if you can get there, right? This also is complementary to what we were talking about before. Invariants are great for SCPs and true preventive controls, right? Things that must always be true and don't require a lot of nuance, right? I'm always going to deny this. Those are great options for SCPs at a higher, more coarse-grained level. Finer-grained controls implement those in proactive, and be able to enforce it in the pipeline, and then just enforce people to push those changes through your pipeline, right? So as a review, again, use policy as code models to sort of make those controls, one, codified in a standardized model and more approachable from people who aren't necessarily code experts, right? Align those objectives to a security framework of your choice and always follow that framework, right? Use preventive controls to protect those security baselines and invariants, and proactive controls to stop those configurations from being introduced into your environment, and then monitor and actually test the controls to make sure they're actually doing what you think they're doing. And so with that, I'll hand it over to Inforce to take us into cloud governance for developers.
Thank you. So I'm going to start with a few scenarios that, sometimes our developers have told us that they've experienced at their organization. Their financial team will sometimes tell the developers, don't spend too much. Their security and central IT teams will ask, who has access to this resource? As well as, can you confirm that you're following our best practices? And then finally, the developers themselves will want to have more development environments and tools. So what can we do to enable security and governance controls while at the same time focusing on improving developer productivity? The developer environments are becoming more and more complex. There's more services, tools, and products that they have to be using. But if we can help developers code faster and more efficiently, shipping features, then it's going to have a large impact on the organization, including increased revenue and possibly a better customer experience for the products. So this brings us to our 9th best practice for developers. Use and govern infrastructure as code to ensure repeatability and consistency. And over here, it's best to have a set of well-architected and standardized patterns for your developers to pick off the shelf and get started with using. They can quickly use them to build their applications based on the patterns as components, saving them hours to weeks of efforts. As an example, it could be RDS databases or instances that are already pre-configured with security and networking configurations, all the way to AWS or solutions with API Gateway, Lambda, step functions, and DynamoDB. It's much easier if the developers could just get started with using it. And you can do that with Terraform modules, CDK modules, or Service Catalog products. With Service Catalog, it does have certain functionality that you might find useful. You can share it across your multi-account environment, but if you make a change to a Service Catalog product, that change propagates across your multi-account environment. There's also self-service actions that you can provide to your developers, such as governed operational actions, making it simpler for your developers to execute snapshots and databases of RDS and Redshift instances if they need to, and you can do that with Systems Manager automation documents. On Service Catalog, it supports both Terraform and CloudFormation. The Terraform launch is relatively new, and it supports open source Terraform, but lets you launch Terraform configurations in a self-service manner. Now, on infrastructure as code options, just a note here, there are many, and the advice here is select the infrastructure as code tool based on your use case. One is going to be preferred over the other, as well as consider what your team is most comfortable with and has the experience with. As long as it helps with repeatability and consistency, that's the goal that we're going for. Now, the 10th best practice, which is detect security vulnerabilities in your code. Here, this is all about the concept of shifting left for developers, improving testing quality and performance right during the development lifecycle. And just like Eric talked about with the preventative controls using CloudFormation hooks, we'll want to catch non-compliant resources from before they're being deployed, right as the infrastructure as code templates are being developed. You can also build out permission boundaries that gives flexibility to the developers to create IAM policies on their own. Code Guru, Code Whisperer help you scan the code for security vulnerabilities, and then Code Whisperer also suggests code snippets and functions based on your code and comments. And then with Amazon Code Catalyst, it's a unified software development platform that lets you organize your projects together, as well as helps your developers collaborate and communicate, launching similar blueprints from their projects. So the key takeaways here: use and govern infrastructure as code to ensure repeatability and consistency, and then detect security vulnerabilities in your code, shifting left for your developers, right during development. So this brings us to the conclusion of this session. We hope you'll go back and set some goals on cloud governance and implement the 10 cloud governance best practices that we shared here today. We thought this quote summarizes it quite well. A sound strategy starts with having the right goal. Thank you very much for attending. Please fill out the survey, and we'll be right here to take in any questions or topics. Thank you. Thanks.